You got the touch. You got the power. Yeah!
Hello and welcome to AI in Games. I'm Tommy Thompson, you're listening to Stan Bush, and today we're talking Transformers. This video looks at a series of games to highlight the continued advancements of artificial intelligence in commercial games, with a focus on two third-person action games based on the ever-popular Transformers franchise, War for Cybertron and Fall of Cybertron, developed by High Moon Studios and published by Activision in 2010 and 2012.
You're a skilled fighter, but you shouldn't be out here alone. Autobots are no longer safe in Iacon.
However, before we start in earnest, we're actually picking up on a video we recorded a long time ago. The story ahead and the games involved relate heavily to our previous discussion on the goal-oriented action planning technology used in the Fear trilogy. If you've not watched Facing Your Fear already on AI in Games, I'd strongly recommend you check it out before we go any further. But hey, if you're still with us, let's transform and roll out. The goal-oriented action planning method was adopted for the non-player characters in the first entry in the series, Transformers War for Cybertron, released in 2010. The idea behind this is that given GOAP adopts a planning light method of search, it provides quick and simple solutions for non-player characters to react to the player's behaviour. GOAP caused quite a bit of a stir on its release, and Fear to this day is still hailed as a great example of NPC AI for first-person shooters, and as such, a number of developers sought to adopt it. One of which, naturally, was High Moon Studios, coming off the back of their recent difficulties in applying AI in The Bourne Conspiracy. Naturally, the adoption of GOAP brought benefits of these autonomous goal-directed NPCs that would keep players on edge, but it, in turn, introduced limitations that resulted in alternative approaches to planning being considered.
Our defeat would mean the end of everything. My victory will mark a brilliant new beginning. One shall stand. One shall fall.
To give some quick background, War for Cybertron is a third-person shooter, during which players must fight through waves of the opposing faction, be they Autobots or Decepticons. Given this is the Transformers, players have the ability to transform at any time from their humanoid robot form into a vehicle. These vehicles can be cars, tanks, planes, typical transforming fare. The GOAP system was used in order to control each of the NPCs that are part of the gameplay. We can often see a lot of these NPCs in action at any given time, since the game likes to focus on large-scale combat. However, this started to cause some problems, which ultimately led to some concessions by the developers. The reason behind this is that it proved challenging to translate the desired behaviours into the GOAP system. As acknowledged in our Fear video, the emphasis in GOAP is on crafting goals that the AI can achieve and then coming up with any solution that satisfies them. However, this means that the suite of possible behaviours is at the mercy of the planning system rather than the designer. Now this might sound okay as an observer, but ultimately designers still want to assert some control over what the AI does in the game. In this instance, we're dealing with a large range of Transformers, which should result in styles of behaviour to help the player interpret not only what they're fighting, but how best to counteract it. To add to this issue, AI developer Rory Driscoll explained that in War for Cybertron, the system couldn't specify costs of plan actions on a per-character basis. This has a real impact on our previous point, given that you couldn't make, for example, running actions less desirable than flying for a Decepticon that transforms into a jet. This would be a really desirable feature, given you could then tune how each class of AI interprets the world. So in some cases, we have AI acting almost out of character, resulting in the designers sometimes ignoring the AI system and crafting sequences by hand in the final product. There was also the issue of resource consumption, given that you would have many bots planning fairly frequently, and that was going to take up CPU and memory, when we can't afford to give it an awful lot in the first place. This was compounded by the GOAP Planner's precondition system being rather expensive to compute and resulted in some overheads in what was already an expensive planning process. As explained by AI developer Troy Humphreys, this was resolved by storing the entire search space in memory, allowing for a quick lookup of plans to execute, but at the cost of having to spend a lot of memory just to keep the search space around in case it was needed.
But, Megatron, how do we get out? Soundwave, report!
Clearly this was going to turn into a dead end. Not because the technique didn't work. I mean, sure, it had technical issues, but that's just par for the course in game development. But it simply wasn't behaving as intended for the level designers. With War for Cybertron completed, the AI team looked into an alternative approach, and it led them to work adopted in the Killzone series developed by Guerrilla Games. In Killzone 2, the AI team used a particular type of planning system known as HTN planning, and High Moon decided to try it out themselves. Hierarchical Task Network, or HTN planning, is a principle of partial order planning that was pioneered in the 1980s and 1990s, by the likes of Austin Tate at the University of Edinburgh, David Wilkins of SRI International, and Dana Now of the University of Maryland. HTN planning takes the same principles as before, but the emphasis is on constructing intelligent high-level behaviour rather than working from simple actions towards goals. One of the legitimate issues of using traditional planning is that as a designer you place more emphasis on the individual actions and how these will all help in some way or another to reaching a goal. This means that while the system is versatile and can combine collections of actions that are useful, it doesn't focus on the larger behaviour it's exhibiting, and this is where HTN becomes really useful. In HTN planning, you model the world using what is essentially macro actions, also known as tasks, combinations of actions that make more complex behaviours. Like regular planning, these carry their own preconditions and effects. However, unlike regular planning, we only need to consider the preconditions at the start of the task and the effects that the complete series of actions within that task will have on the state. We can break down tasks into two distinct types: primitive tasks that are comprised of traditional planning actions, or compound tasks that use not only primitive actions but also other compound tasks in order to complete a problem. These help solve larger chunks of planning, given that a task network can solve a subset of an entire planning problem and introduce several actions for the agent to execute in one fell swoop. This allows you to model more complex behaviour really quickly. There is an obvious benefit also for game developers who are new to HTN planning. If we consider this image, taken from work by researchers on the SHOP 2 planner at the University of Maryland, it shows a final HTN plan that can satisfy a particular logistical problem. This results in a tree-like structure where users would navigate and execute actions from the left to the right. This tree-like structure and the order in which we execute it is incredibly similar to that of behaviour trees, the default AI tool in Unreal Engine 4 and popularised in game development largely through the Halo series. However, unlike behaviour trees, an HTN plan is constructed in real time based on the current goals and state of the agent. If you're not familiar with behaviour trees, be sure to check out our video on the Halo AI already on AI in Games. So how does this work with the Transformers games? Well, let's have a look at how it paid off for High Moon. After releasing the movie tie-in to Transformers Dark of the Moon, High Moon's next title was War for Cybertron's sequel, Fall of Cybertron. Having refined and iterated on much of what made War for Cybertron great, Fall of Cybertron is, in my opinion, the best game High Moon Studios has ever made. Fall of Cybertron replaced GOAP with HTN planning, and results in a number of task networks being defined for characters. Multiple primitive tasks are established per character, with unique conditions that dictate when they might execute, so as to inject a little diversity in the gameplay. Meanwhile, compound tasks would carry multiple tasks within them whose preconditions would dictate how the NPC would behave. This allowed, for example, attacking behaviours to vary depending on the distance and visibility of the non-player character's target. Ultimately, designers have a lot more control over the intelligent behaviour these characters are exhibiting, given that the HTN method is adopting this rather expressive, top-down approach to behavioural design. This subsequently led to gains in overall performance, as AI planning researcher Eric Jacopin discovered when profiling the planning systems in Fear, Killzone and Transformers Fall of Cybertron against one another. The HTN implementation not only yielded longer plans faster, but also utilises more of the available planning actions available to it than GOAP did in Fear. Although Jacopan himself was keen to point out how the differences in AI implementations would naturally have an impact on performance, and thus wouldn't declare a winner or loser in this discussion, since each clearly achieved their goals in their respective games. However, it does clearly establish that HTN planning is a viable alternative to the use of GOAP and its strips-based method, previously established in Fear.
That's it! Put him down! Put him down!
Thanks to the likes of Killzone and Fall of Cybertron, HTN planning now sits comfortably as one of a variety of approaches to accommodate fast and adaptive AI decision making for action games, given it allows for designers to focus on the more complex and abstract behaviour while the AI glues them all together during gameplay. HTN has since grown in prominence and has been adapted in other games, notably Max Payne 3 and even Dark Souls. As always, we've barely scratched the surface, and the written piece that accommodates this video is available on AIandGames.com for those who want to learn more about this in even greater detail. If you've not played the Cybertron series, they're a cracking pair of shooting games and well worth your time. You can find both of them on PC, Xbox 360 and PlayStation 3. As a Transformers fan myself, I have to say they're the best Transformer games ever made, with Platinum's Transformers Devastation not far behind. A great way to wash the horrors of the Michael Bay movies from your otherwise delicate palate. As always, thanks for watching here at AI and Games. If you enjoyed this video, don't forget to like and subscribe. If you're a fan of the Cybertron series, let's hear about your experiences in the comments. And with that, this is Tommy signing off, and it's time to cue the music. The AI and Games series is sponsored on Patreon, and a big thank you as always goes to our supporters on screen now. To learn more, head over to patreon.com/AI and Games. And don't forget the underscores.